I had a request for some review of partial derivatives, and I apologize in advance if you hear my dog jingling in the background. She refuses to go anywhere else today. So a reminder is that a partial derivative of f with respect to x is written as del f del x, and it's the derivative of f, which is a multivariable function of x and y, where y is treated like a constant. And f of x, y is considered then to be a function of just x. And then the partial derivative of the multivariable function f of x, y with respect to y is written as del f del y. And it's the derivative of f of x, y, where x is now treated as the constant. And f of x, y is considered a function of just y alone. So there's our reminder of what we're doing with all these partial derivatives. Let's start our review of partial derivatives with a fairly easy example. So if we wanted to compute del f del x and del f del y for the multivariable function f of x, y equals x squared times y cubed, let's start with del f del x. In this case, we're going to look at anything that is not an x as just a constant. And so that means y cubed here is just a constant. And the only thing we're going to take the derivative of now is the x squared, which is 2x. So our partial derivative of f with respect to x is just 2x y cubed. Now, on the flip side of that, if we look at the partial derivative of f with respect to y, so del f del y, now anything that is not a y is treated like a constant. So x squared is now a constant, and now we only want to differentiate y cubed with respect to y, which would be 3y squared. So we end up with 3x squared y squared. For the next example, we're going to go a little more complicated. Now our function f of xy is 1 over x plus y. So what I'm going to do first is I'm going to rewrite this as x plus y to the negative 1. That makes life a little bit simpler because now when we do del f del x, we know that since it's a function of x and y in this case, we can say that we bring down the power, the negative 1, times the function x plus y to now the negative 2 times the derivative of the inside. And this is where the partial derivative comes into play, because what is the partial derivative of x plus, let's say, 1? Remember, y is just a constant. It's like a 1 or a 5 or a 10. So the derivative of that would just be the x, which is 1. Derivative of x is just 1, so we end up with negative 1 over x plus y quantity squared. And in this particular case, what's going to happen is now when we look at del f del y, funny thing is we're going to end up with the exact same thing because we still have the negative 1 times x plus y to the negative 2. But now the derivative of the inside with respect to y, now we're going to pretend like it's essentially 1 plus y. Well, the derivative of 1 would be 0, and the derivative of y would just be 1. So in this particular case, we end up, funny enough, with the exact same partial derivative. It's not all that common, but it happens sometimes. We're going to mix it up just a little bit now with g. So in this case, we're looking g of xy is y over x plus x over y. My first suggestion is let's rewrite this a little bit. So let's rewrite this as g of xy equals y times x to the minus 1 plus x times y to the minus 1. That's going to make life a little bit easier on us when we want to go take our derivatives. So let's start with del g del x. Well, if we take the derivative of y, x to the minus 1, y is considered a constant like 2 or 5. So y is just along for the ride. And now the derivative of x to the minus 1 is going to be negative 1 times x to the minus 2. So that's the first term. The second term, now remember, we're only taking our derivative with respect to x. So the y to the minus 1 is considered a constant here, and the derivative of x with respect to x is just 1. So we end up here with, let's see, negative y over x squared plus 1 over y. Sorry for the barking dog. I think someone came home. So if we look at del g del y, though, things will be just a little different. So in this case, now anything that's not a y gets treated like a constant. So when we're looking at y times x to the minus 1, x to the minus 1 is treated like a constant, and the derivative of y with respect the derivative of y with respect to y is 1. And for the second term, the x is considered a constant, and the derivative of y to the negative 1 with respect to y would be negative 1 times y to the negative 2. So here we end up with 1 over x minus x over y squared.